Okay, right triangles. This whole chapter is right triangles.
Oh my nose.
So we just got done doing if you have a big right triangle with an altitude, you can find a missing value by writing proportions. If you remember, this is a geometric mean, this is a geometric mean, and this is a geometric mean. So if you know these two lengths, you can find these three. If this is 8 and that's 12, x is a geometric mean. And when you put this leg in there, you put this piece and the entire length, which is 20. So when you solve it, it'd be x times x squared equals 8 times 20 is 160.
Yeah. Okay.
So then you got to square root it, round to the nearest tenth, and you get 12.6. If you're looking for y is a geometric mean. So you put that in there twice. And then if it's the middle piece, you just put each part, 8 and 12. So this would be y squared equals 96. So you got to square root it. It'd be 9.8. And then z is a geometric mean. If you do this leg, you got to put this piece over the whole thing. So you got three different proportions. So this would be 12 times 20 is 240, so z squared equals 240. So you'd square root that, and you'd get 15.5. Okay? Now, it's not always these that are missing. If you have something like this, it's the same thing. You just need to know how to set it up, and then you just put the values in there. 8 is the geometric mean, so that goes in there twice. And when it's this piece, you put x and 12. So it'd just be 8 times 8 divided by 12. And you get 5.3 repeating. Okay? If, we'll say this is 16 and that's 12, and they're looking for this right there, you can't find x right away, but you can use the proportion for this. 16 goes in there twice, and you put this piece and the entire length, which doesn't have a label, so you just call it whatever you want. Call it y. So it's 16 times 16 divided by 12. It's 21.3 repeating. So now that I know that, now I can figure out what x is, right? By just subtracting 12 off of that. And you'd get 9.3 repeating. Okay? So, these are the right triangles where we have 3 right triangles in one. Now, this lesson is stuff that you did in 8th grade, the Pythagorean theorem. Pythagorean theorem only works in right triangles. You can only use it in right triangles. And what this is if you know 2 sides, you can find the third. So in any right triangle, if you know 2 of the sides, you can find the third side. And it can be any 2 sides. Anyone remember what the Python
A
is on the
squared plus
board?
B squared equals C squared.
A squared plus B squared equals C squared. A and B are the legs. C is the hypotenuse. So you need to know how to distinguish which is the hypotenuse. Hypotenuse is always the longest side, and it's always the one opposite of the 90. Okay? So, and this one, 4 and 3 are the A, so if you figured it out, it'd be 3 squared plus 4 squared equals x squared. A squared plus B squared equals C squared. So when you solve it, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So then you would have to figure out x by square rooting. To get rid of a square, you square root, and you get 5. Okay? 3, 4, 5 is a very common right triangle. So here's one where the hypotenuse was missing. You might have the triangles where a leg is missing.
Bless you.
Okay? So if a leg is missing, you do it the same way. You use the Pythagorean theorem. It's x squared, because that's a leg, plus the other leg squared, equals the hypotenuse squared. And then you solve it. So x squared plus 12 squared is 144, equals 20 squared, 400. So we got to subtract 144. And that's 256. So then when we square root it, you get x equals 16. Now, you should always look back just to make sure when you're done that the hypotenuse is the longest leg. Here 20 is the longest, so I probably did it right. Here 5 is the longest, so I probably did it right. A common mistake people do here is they just look at them and they get this stuck in their mind, plus. They'll go 20 squared plus 12 squared, and then they'll solve it that way. 20 squared plus 12 squared, square rooted, is 23.3. So if you look back, you'd see that that's not possible because this has to be the longest. So if you get something that's bigger, that just means you added when you should have subtracted. Now, the shortcut for this, it's very easy just to punch it in a calculator to find the answer. Because again, you know one of two things. You either know the two legs, or you know hypotenuse in a leg. Okay? Yeah.
Is there a theorem like to find the third side if there's like if let's say it's not a right triangle, you want to find the third side? How would you do that?
That is, you got to use the law of sines or the law of cosines, which is trigonometry, which you do in your senior year. Okay, so the shortcut is, if it's the two legs, we know we got to add them. 10 squared plus 7 squared, and then you always, the last step you always do on this is square root. Because if I wrote this out, it would be 10 squared plus 7 squared equals c squared. So I'd have to add these together. I'd get 149. And then I'd have to square root it. So, depending on which calculator you got, these calculators, you'd go 10 squared plus 7 squared, press equals, and then you square root, and we get 12.2. On those calculators, you got to put the square root sign first. So you put the square root sign, and then it'd be 10 squared plus 7 squared, press equals, and you'd get the answer. On this one, if you're looking for a leg, it's basically the same thing, except what do you got to do? Subtract. And you gotta do the bigger one first. It's 12 squared minus 9 squared, square rooted. The reason why is if I solve this, there's the leg missing, plus this equals the hypotenuse squared. So I'd have to figure it out. So I would subtract 81 to get rid of it, and that's what I'm doing here, 12 squared minus 9 squared. And then the last thing you do is square root. And that's 7.9. So again, if you look at the hypotenuse is the longest. The hypotenuse is the longest, so I probably did it right. So that is what we're doing today. Okay. Find the length of the hypotenuse. So when it's the hypotenuse, it's a squared plus b squared. So I just got to go 15 squared plus 8 squared and square root it. And it's equal to 17. Okay? Now, this right here, a Pythagorean triple. The Pythagorean triples are all three sides are terminating numbers, which means, like on these I did over here, I had to round one of the sides. So basically, it's a Pythagorean theorem if you don't have to round. So did I have to round? Are any of these rounded?
No.
So you would just put yes, this is a Pythagorean triple. The most common Pythagorean triples are a 3, 4, 5, like the first example I showed you. You can double that. 6, 8, 10 is the second most common. You can triple it. 9, 12, 15. You can quadruple it. 12, 16, 20, and so on. Other common ones are 7, 24, 25. And then you could double that and get 14, 48, 50. And you could keep on going there. They don't always have to be whole numbers though. You could have, as long as they're not rounded, like you could have a 1.2, a 1.6, and a 2.0.
Okay, sore.
Okay? These are decimals, but they haven't been rounded. So this is also a Pythagorean triple. Okay? On your calculator. You know by looking if you got to round it. So like say you got 2.1573, or whatever. It's not a Pythagorean triple. Okay, so to find a leg, remember the shortcut is you only add them if you know the two legs. So if you don't know the two legs, you subtract them. It'd be 20 squared minus 15 squared. You do have to do the bigger one first. If you did it backwards, you'd get an error on your calculator. So 20 squared minus 15 squared. You got to remember to press equals on these. And then hit square root. This one I'd have to round. So it's 13.2. Round to the nearest tenth. So then if they ask, they didn't, but is this a Pythagorean triple? No, because I rounded that number. So it's one of two things. If it's the hypotenuse, now does everyone remember how to spot the hypotenuse?
Well, the one right.
Yep, opposite of the 90. The two legs form the 90, so it's the ones that don't form the 90. If it's the hypotenuse, you square them and add them, and then square root. So this one I do have to round, which means you would put no, because it asks, is it a Pythagorean triple? If it's a leg, you gotta subtract them. It's 25 squared minus 24 squared, square rooted, and you remember what that is from what I put up? It's 7. So x is 7, so you would put yes, it is a Pythagorean triple, because I didn't have to round anything. Okay, areas, remember how to find areas?
Yes.
Of a triangle, I mean?
When you cut it in half.
Base times height divided by 2. So, here I know the base is 18, but I don't know the height. So what we gotta do is figure out what the height is by using the Pythagorean theorem. Since these two are the same, and this goes straight down, that means this would get cut in half, it'd be 9. So, could you figure out what h is?
Easy, you just do.
Do you add them or subtract them?
Equals
Subtract.
12 over 30.
12 squared minus 9 squared, and you square root it. Should be 6. No, that one's rounded. It rounds to 7.9. Now, here's how you can get a more accurate answer. If you just leave this number on your calculator and then type it in, take the height times the base, and then don't forget you got to divide by 2. So now you can round, it's 71.4 square inches. Now, it might be a little different if I do write that down as it rounded. So if I put it in 7.9,
It's 71.1.
71.1, so it makes a difference if you round or not. But I can tell if you did it correct, so either one I would count, I'd count right. Everyone know the difference what I did here?
Yeah.
Here I used 7.9, here I used the actual long number that was on the calculator.
Oh,
Okay, so that's the rest of it is just finding the area. So to find the area, it's base times height divided by 2. So we gotta find the height. So since these are both 9, this would get cut in half, that's 7. So you would go 9 squared minus 7 squared, square rooted. And it's 5.65 or 5.7. So again, you got a choice. The easiest is just to leave this number on your calculator, not rounded, after I do this. And then go times 14, divided by 2, and then round it. 39.6 centimeters squared. If I would have used this number, times base times height, divided by 2, I would have got 39.3. Which is okay, it's just this is the more accurate one. Okay, so the same thing here, we got to take the base times the height divided by 2. But I got to find the base first. So again, since it's a leg you're looking for, you got to go 21 squared minus 10 squared, square rooted. And it would round to 18.5. But again, just leave this on here. Take this 18.466, so on, times 10, divided by 2, and then round, it'd be 92.3 feet squared. Okay, everyone got it?